All right, for part 2 tonight, we're going to look at a couple graphs and you're going to go the other way. So I'll show you 3 and give you these 2 to do in your comp books. So normally I give you the equation and you give me the graph. So now I give you the graph and you give me the equation. So let's go ahead and see what kind of values we need to change in this function. So first of all, is it a sine or a cosine curve? It could be either, but let's go from the one that's simplest. I see it starts high and goes down, so I'm going to call that a cosine curve. So I'm going to start with y equals cosine of x. So that is the beginning but not the end, because I also see instead of going up 1 and down 1 like a normal cosine, it starts at 4 and goes down to negative 4. That's a change in amplitude. So the amplitude number is always in this position in front of the trig function, the name of the trig function. So when we do that, we have noticed that the period is 2 pi, which is normal. So we haven't shrunk it or stretched it. And we have it go the center line, it's going around 0. We haven't moved it up or down. So that's the answer, 4 cosine x. 4 representing a change in amplitude. Can you see the change in this one? First of all, before I put it down, decide for yourself, and you'll have to stop the video to copy these down and turn it back on and see if you can tell me what changes have been made. Alright, hopefully you had a chance to think about it. And this one I'm going to call a cosine curve as well, because of it starting up the top and then going down. And I am wondering if the whole thing hasn't been raised up. The way I tell is I cut the graph in half, like this. Like when I cut this one in half, yeah, I can see that the center line is normal, at 0. But this, when I cut this in half, I see it's at 3. 1, 2, 3. So that tells me the whole graph had been raised up 3. So I can indicate that with a 3 in the front or the back. So I'll put it up here. 3 plus. And I also see that from the center line, instead of going up 1 and down 1 like a normal cosine, it goes up 3 and down 3. That's an amplitude change. So I put that right there. So we have the name for this graph. It had the normal period, and it wasn't stretched out or shrunk because it had the normal period. And only its amplitude and its horizontal and vertical value has been changed. It was not shifted to the left or right. Alright, let's come up with a name for this one. Can you see these values? This is the ones up to 3, down to negative 3. The normal tick marks are not on here. This says pi, 2 pi, 3 pi, 4 pi. I don't know if you can see that well. And this is negative pi and negative 2 pi. See if I can zero in on that just a little. Hold on to your seats. Alright, so looking at that graph, you can see that this is negative pi, negative 2 pi, negative pi, this is 0. Pi, 2 pi, and 4 pi. Went up to 3 and down to negative 3. Alright, so what is the name of this curve? This crooked looking curve. Sorry. I do need a cameraman. Alright. The name of this one, I'm going to call it a sine curve because it starts at the origin like the sine curve does. So I'll start with y equals sine of x. Then I see from there it went up 3 and down 3. So I can add an amplitude change of 3. Finally, the whole curve is not moved up or down, so I'm not going to add anything to either side of that. And now you can't see that. Alright. Alright, so I have y equals 3 sine of x. And I notice the whole thing does not take place in 2 pi. So that change takes place in a position that we call k, when we stretch it out longer or shrink it. So normally one mountain and one valley would take place in 2 pi, but this took place in 4 pi. So we have to calculate our value k. And k exists right there between the word sine and the variable in the problem. So we're going to stick in a k there, and we got to calculate k. So k is the key, is always the old period, 2 pi divided by the new period. Well, I can see the new period in one mountain and one valley took place in 4 pi. So simplify 2 pi divided by 4 pi, and you'll get 1/2. That is our k. So that's the value for this graph. All right, I'll show you 2 more. So pause the video and sketch these 2 curves. And let's see if I can get them in pretty well. I think that's good. So this we'll call problem A and problem B. So on curve A, notice it went up to 5 and down to -5, and the whole thing took place in pi over 2 radians. So you can kind of ignore the rest. This will get you the answer. So look at this spot for your answer, for your equation. All right, down here is your second problem, and this one goes up to 2 and down to -2, and one whole cycle takes place, looks like it's a little off. I would like to say it took place in, I want it to look a little like that. It's hard to say. I'll describe in words what I mean. 3 pi over 2. So 2 pi. I'd like you to look at one full period. So it would be mountaintop to mountaintop. So mountaintop here starts a little bit to the left of 0, and mountaintop here a little to the left of 2 pi. To get the equation, you need to know how far. And I'll say that from here to here, this mountaintop is taking place at -pi over 8. So it's just a little bit to the left of what a normal curve would be. So this mountaintop is at -pi over 8, and this mountaintop is not at 2 pi. It is also pi over 8 to the left of 2 pi. So see if you can come up with that equation. It goes up to 2 and down to -2, but the whole thing was shifted to the left, shifted to the left pi over 8. All right, with that, those 2 problems, does that show up? Let me see. Yes, I think it does. All right. So that's all for us tonight. Good luck with those when you come into class. We'll see if you were able to come up with the equations of these sinusoids. All right, till then, bye.